Very good morning to one and all present here, and thank you for joining us at 3-day international conference on computational techniques and intelligent machines in collaboration with IEEE Computer Society, Waterloo Section, Canada, MSEST, Morocco, and SIRG, Egypt. It gives me an immense pleasure to welcome all the participants today for the 3 days international conference ICC TIM 2020. I welcome all the eminent speakers and guests from all over the world to share their knowledge and vast experience with the community. So we are going to start the first session of our conference, and the theme of the first session is advances in computational intelligence and its applications. In this session, chairperson we have is Professor Dr. Jenkin Whitson. Co-chairperson is Professor Upinder Kaur. For the plenary talk, we have Professor Dr. Valentina Emilia Vala. And for the invited talk, we have Professor Dr. Jenkin Whitson. We have received more than 300 research papers in this conference from all over the world. And in this session, we have 6 presentations of different delegates. So I would like to introduce for the plenary talk Dr. Professor Valentina Emilia Vala. Dr. Valentina is currently working as a professor in Department of Automatic and Applied Software at Faculty of Engineering, University of Arad, Romania. Dr. Vala is authored of more than 350 research papers in refereed journals and international conferences. Her research interests are in intelligent system, fuzzy control, soft computing, smart sensors, information fusion, modeling and simulation. She is also the editor-in-chief of International Journal of Advanced Intelligent Paradigms and International Journal of Computational System Engineering, member in editorial board, and also act as an expert evaluator for national and international projects and PhD thesis. Dr. Bala is the director of Intelligent System Research Center in the University of Arad and also the director of Department of International Relation Program and Projects in the same university. So I would like to invite eminent Professor Dr. Bala for her plenary talk. So I am now handing over the mic to Professor Bala. Ma'am, please.
Good morning again. And now we will start the talk very soon. Is it visible or not? Not yet.
Yes, ma'am, it is visible.
Okay. So the topic of the conference, your conference in computational techniques and intelligent machines, is fitted perfect with the topic of my research and the topic of our team in Arad too. So I will introduce you some techniques and many applications we will discuss here in this presentation. You can see the content of my presentation. I will introduce you some methodologies and then some controllers that are typical for different process, highly nonlinear and with many uncertainties there. And then I will introduce few applications. Maybe the time will be not enough. I have in front of me 30 minutes or 45 minutes, maybe 30 minutes presentation, yes? So I will skip some slides because there are too many, and we'll introduce you in few applications that we develop along the years, and some of other applications still are under development with very, very good results. Finally, some conclusions. And I will explain you to every application what we have done and why we started. So we are looking for a tool that can control any kind of process, highly nonlinear process, and with very good results. You know, as the conditions are very hard, systems are not working properly. There are many technical and traditional optimizations, techniques and methods that were successfully applied in the last years with a well-defined structure and configuration. So in the case when we know very well to describe, how to describe and to have a perfect model of a system, it's very easy to work with. If there are some problems that are coming there and uncertainties are coming, perturbations and so on, there are a lot of problems around and we need to control that process. So some optimization problems are usually very well formulated by crisply specific objective functions and specific systems of constraint and so on. But real world situations are often not deterministic to be able to organize a good model and to control everything. This is our real world. Also, there are many type of uncertainties in social process around, in industrial, in economic systems, and everywhere around us, such as randomness and occurrence of events, imprecision and ambiguity of systems, data and linguistic vagueness, and so on. There are including here a lot of errors from the measurement side and deficiency in history of statistical data, sometimes insufficient theory, incomplete knowledge expression, and subjectivity and preference of human judgment. As an introduction, because we are working mainly with tools like fuzzy logic and neural fuzzy systems control, the fuzzy set theory was introduced, as you know, by Professor Lotfizadeh, and this represents a tool for representing some symbolic, linguistic, and qualitative knowledge into computers. On the other side, it's another big scientist, Professor Michio Sugeno, that introduced us to fuzzy controllers that can be feasibly applied in any engineering applications. Here we are all together in 2007 in Oradea, a city not far from. We, all of us, are instinctively using linear interpolation in any activities. And this is for sure a basic reasoning technique. Using a polynomial spline, like in mathematics or any other kind of interpolation, is not bringing significant advantages in usual automat control applications, not to talk about their specific cost that arrive here. And comparing interpolative network to neural networks, we can see that interpolative networks are not suited for automat learning, and neural networks are designed for automat learning. Interpolative networks are not hiding information, but neural networks are hiding it. Here, a conclusion that interpolative networks are capable to embed this knowledge. In our approach for design smart or intelligent systems, we are using this methodology that was introduced originally by our team, fuzzy interpolative methodology. In classical automatics, we are using a perfect deterministic model. So we are able usually to have a mathematical model, and we compare what is happening in reality in our real system with what is happening in a model that can be made to be very, very near to the reality. But in many situations when the systems are very complex, we cannot organize such a precise model, and we need to switch to other methodologies. So we introduce this kind of fuzzy interpolative controller that is a fuzzy controller that can be equal to an interpolative network. I described firstly some interpolative network to you, and I told you that humans are usually instinctively using interpolation. And this kind of network, it's with linear interpolation, each fuzzy controller having a corresponding interpolation node, easy to organize. So the next result is a linguistic fuzzy inference that can be implemented very easy in MATLAB Simulink by lookup tables and other similar tools, even by integrated analog circuits. Another concept that derived here is the fuzzy interpolative expert system, and fuzzy interpolative methodology we will try to develop slides. Only a few words, because it's not so easy. We develop this methodology along some good years. We use in our development three main ideas. First, we started from the works of Professor Zadek, Sugeno, and Bauer. And we all know about these Sugeno fuzzy controllers, that they can approximate any finite n-dimensional function with an arbitrary precision. If we have many such triangles, we will be able to approximate this curve that you can see on the upper side. If we will put only few, we will obtain such an approximative line that approximate the curve line here in this figure. But as the granulation is bigger, we will obtain very, very near results to the curve that we propose to approximate. Then it's another work that we introduce here from Stoll, that said that linguistic design method through which any given transfer characteristics may be approximated by means of fuzzy controllers. And the last one, works introduced by Cloxin and Morgan, and this professor from France, Laurent Foulois. This is related to qualitative control method that is based on the real-time online qualitative analysis of the error phase trajectory. This is a very well-known tool in fuzzy interpolative controller. This concept must not be confounded with another concept that is fuzzy rule interpolation. It was originally introduced by Professor Kotzi from Hungary and Hirota from Japan. Such a specific Sugeno controller with an immediate linear interpolative equivalent is using triangular fuzzy partitions, prod sum inference, and center of gravity defuzzification. And its specific interpolative counterpart is the lookup table with linear interpolation, very easy to develop in MATLAB Simulink. In closed-loop control applications, fuzzy interpolative controllers are matching a fundamental time analyze tool, that is the phase trajectory of the error associated with the quantitative analyze. So this tool is very well known in automatics trajectory of the error, introduced here in this slide. And you can see in this figure, we have the error and the derivative of the error. As we are doing the analyze for any controller. So our dream is to arrive to the error and the derivative of the error in the center, so being zero. Coming on such trajectory is coming to the zero error, so it's a trajectory that we want usually in our control systems. This is the phase trajectory, so phase or phase plane. In the same time, we can see here these three important directions that we need to cope in our analyze. So the phase trajectory of the error is this one. Then the second one is represented by McVicar-Velan tables organized in MATLAB Simulink. You can see such similar trajectory, but we have here in every piece here, we have a rule. Here we have a number, but backside it's a rule. And in the third time, we have interpolative networks that are lookup tables where we implement our fuzzy interpolative methodology.
Ma'am,
yes.
Your presentation is not visible.
It's 1 hour presentation.
It's not visible on the screen. We are not able to view your presentation.
Oh, why you are not saying that you cannot see my presentation? I asked first, and you said you can see is visible because you cannot understand. Now I hope you will see. Yes or no?
No, ma'am, it's still not visible.
Okay. Now I think yes. Yes?
Ma'am, it's visible now. Yeah.
It's visible?
Yes, ma'am.
So I need to explain again some few words because you cannot understand. Just a moment, please. So very, very fast going. These are the first I have introduced you. Here are Professor Zade and Sugeno that are the main person in this field and that inspired us our work. Then I explained here that interpolative networks, we are going to neural network, how different are interpolative network capable to embed and process knowledge. We are interested in such statistics. I told you going to see this methodology. The support is here, coming from these three different works. And here I explain you that as much granulation is going up, we will approximate this curve. In this situation, we are approximated by organizing such triangle, but upper side we will have some small pieces very near to the original one. Then I said that it's very important to see the phase trajectory of the error, that is a very important tool in automatics. And we are speaking about qualitative. And here it's important to understand the concept. Here is the phase trajectory of the error. And I explain you that we have here the error and the derivative of the error, the change in error. We are interested to see the error 0. So this trajectory, it's a good trajectory that we are looking for. The phase trajectory of the error in phase plane. Then is the McVicar-Velan tables. You can see they are somehow following the same trajectory going in the center where the error is 0. And then we are interested in introduce this tool in lookup tables. Very easy. You can see some numbers here, but backside there are important knowledge in automatics, in classical automatics. So it's true, to understand the fuzzy control, you must understand first automatics, classical. And I arrive here, and there are some important things to tell you that fuzzy interpolative methodologies is taking advantage of both linguistic and interpolative nature of the fuzzy system, and combining these two advantages. First, the fuzzy set and logic theory will be applied during the conception and the development stage of the control algorithm, and second one, the linear interpolation will be ensured the implementation stage. Here are some steps that must to follow. First, the identification of the control solution, then building of the control rule base of the corresponding fuzzy expert system, then the designing of Sugeno controller with triangular fuzzy partition, prod sum inference, and center of gravity defuzzification. And on the other side, we have the design of the corresponding lookup table to implement it. This lookup table with linear interpolation, and another idea, the implementation of the lookup table. So we will develop, but we need to implement, or which are the tools to implement. So such controllers that we started to discuss can stand for the best control solution, but only if we provide with the relevant knowledge about specific control process and about the control theory. This knowledge becomes compatible with controllers in the case that can be modeled. So models can be used either directly as internal models included in the control algorithm, or indirectly by assisting the design. If we have a precise idea about how we want the system to perform, we can design planned control systems. But lookup table techniques allows the introduction of these elements of incipient world knowledge. It's a term introduced by Professor Zadek. So world knowledge are some knowledge that we along our experience. Here in this slide, we have FPGA implementation. So the interpolation processor block diagram its upper side, and then we use an Altera board of a FPGA to develop some applications, because in the beginning we were organized some applications over some simulations, but it's important to have real applications, and we try to propose, especially for Japan specialists, some possibilities to have a specific circuit to implement their our controller. But they were not much interested, and we find very easy solution using an FPGA where you can immediately develop any kind of application. So we organize such applications along some diploma thesis and master thesis dissertation with students, and applications were very, very well responding to all parameters. Now we will try to see the family of these fuzzy interpolative controllers, and there are three that we developed along the years. The first one, member display surface adaptive interpolative controller, that is a variable structure of a fuzzy interpolative controller that is PD, proportional derivative during the transition regimes, and that commute in a gradually linear interpolated manner to a PID while entering in the steady regimes. Another member of this family is fuzzy self-adaptive interpolative controller. So it's an adaptive controller that is a plain surface adaptive, but with a multiplicative adaptive corrector that is realized by the help of the fuzzy interpolative PD controller. And the last one, member of the family, fusion fuzzy self-adaptive interpolative controller, that it is obtained by the fuzzy fusion of several adaptive correctors into a single fuzzy self-adaptive controller. Thus is resulting a controller that is able to include contradictory control strategies which are invoked accordingly to the behavior of the system. So we are going from the simple to the complicated stage. The last one, it's more complicated, but with the very good results in difficult situations. When the systems are very, very complex. Here we have the plane control surface for an adaptive interpolative controller. You can see the same characteristics that I introduced you, the error and the derivative of the error, and we want to arrive coming from different points in the middle of this circle, so where we have the error and the derivative of the error 0. Here is the interpolative controller and the plane control surface control. The plane control surface controller is compared here to an interpolative controller. Here is the first member of the family, plane surface adaptive interpolative controller. This is composed by a 3D lookup table. You can see the 3D lookup table that are similar, very similar, syncing to all numbers that are included here, but they differ only in the central point. You can see 0 here, and to the other table, you can see 2 in the middle and -2. So we have in such situation a three-dimensional system, because here in the plane phase, we were working only with the error and the derivative of the error. Now we will work also with the integral of the error. So in the middle, we have the integral of the error 0. On the other side, it's positive. On the other side is negative. You are looking in the center. So this is a controller that where the central point, central surface is a PD one, and these are three different PD controllers, different only in the cell. Now we will look for some different possibilities working in MATLAB Simulink, different control surfaces for the first member of the family. We can see these figures with different conditions with peak here another surface, using different methods for integration. The fuzzy self-adaptive interpolative structure is organized using in the middle the first member of the family, plane surface, adaptive interpolative controller, and we are using also an estimator of the state quantities, then an adaptive fuzzy interpolative corrector, and then is the plant that we want to control. We have the input and the output. We have here also a multiplicative corrector factor. So in this diagram, we can see that we have a little bit complicated figure, but it's only the first. And we can see here the results. The Simulink model organized for the first possibility is in this figure upper side, but here we can see how the system is responding to our controller. You can see how the system is responding for a PID controller, and then this fuzzy self-adaptive interpolative controller that show us a very good response. So very easy going to the steady state, and without such an increasing of the surface. So the is good in this case. Here are some possibilities to follow how we are designing such a controller. So the control rules, I will not see all the lines here, only few of them. So we are working with McVicar-Whelan tables, of course, with fuzzy triangular partitions. Akagi-Sugeno inference is broad sum. In this case, we use the fuzzification center of gravity. There are many other the fuzzification methods, and we are using rules that are heuristic, written on the base of qualitative analysis of the phase trajectory of the error, and thus we are adjusting the linear PID controllers. What is interesting here, coming back to the conventional automatics, we know very well that we have different operating regimes that are stationary, transitory, oscillatory, and unstable. We are interested in such transitory and stationary. Oscillatory, we are not happy, but unstable, none. The operating regime may be identified online in real time by the qualitative analysis of the phase trajectory of the error with the help of fuzzy interpolator. So here are the four regimes, so G1, G2, G3, G4. G1 is transitory, G2 steady, G3 is oscillating, and for G4 we are in a stage of unstable. So in every kind of this operating regime, we know that things are happening like this. So gain, we are looking to the gain and to the integrative side. The gain is medium and integrative is 0. For transitory, transitory is going to the error 0, and the derivative of the error also 0. For G2, that is steady, gain is great and integrative is great. For oscillating, gain is small, integrative is 0. And then for the last one that we do not want, gain is very small, integrative is 0. Here are some figure where we can see the operating regime. So this is an oscillatory one going around the origin. We will never arrive in this stage with the error and the derivative of the error 0. And this is an unstable, is going to the plus infinite, is not going to this 0. Here it's a steady regime going to the 0, but following this 4 quadrant, you can see the first, the second, the third, and the fourth, going over all of these, but following 0. And the heuristic adaptive rule base, it's here. Again, it's about the error and the derivative of the error in this table, again here, and with different possibilities, we put here negative, small, and positive for the derivative of the error. And for the error, we have positive grade, positive medium, small, negative medium, and negative grade. So we have here 5 different linguistic terms. On the upper side, we have 3. And the rules that we know very well from the automatic side, we can find in this table, and every piece, it's a rule. We have here 5 multiplied by 3, 15 rules. So G2, when J must be great for a fast response, or medium to reject the overshoot. So every point you can find a rule. Of course, we are interested to go also in the middle of the table where the error and the derivative of the error, it's 0. G is the correction. Fuzzy self-adaptive interpolative is implemented by lookup tables. And we can see here how easy it is to implement. All these numbers have backside this good knowledge from the automatic, the classical automatic. So we will organize this adaptive lookup table, writing every row and column, and using our controller, we will obtain small oscillation for such a system that is a third order system. On the upper side, I have this figure from the Zoom. I don't know if you can see the text and everything. So it's about a third order system to control. Is not easy. And in the phase plane, we can see the error and the change of error, the derivative of the error. But for a classical PID controller, the response is oscillatory, but with big oscillations around this point. That means 0, the error, and 0, the derivative of the error. For our controller, this black line, you can see that the trajectory is more close to the center. So is working better than a PID, a normal. I think I will go faster. I don't know how long I have for my presentation. Please tell me not to keep you here too much. Do I have 15 minutes or 10 minutes or half an hour? Please tell me. Okay, I will speak and you will stop me at the moment. This is the last member of the family, Fuzzy Fusion Self-Adaptive Interpolative Controller. The model is organized again in MATLAB Simulink with different blocks, and We go further. Using here such a controller, we can see the response to a step introduced that for different kind of systems, like this one, it's a second order system, this one is um, time delay system, but second order. This also, it's third order systems with time delay. So these are hard conditions. How is working for a conventional stage and how is working uh, for our fuzzy fusion self-adaptive interpolative controller. You can see in every case, even the conditions are very hard, we obtain at least an oscillatory, but with very small oscillations. The red line here can show you that this controller is working very well, going to the uh, one, to the step one that was applied in the beginning. So here are some observations that show us that this controller has a remarkable potential. So in the case of air conditioning equipments, we are using such uh, controllers. In our city, we have the big factory in Southeastern Europe for railway coaches, for passenger cars. I was working there for 9 years as an engineer in the design. And my husband, we are working together. He was working in pure research, doing research in such railway coaches. And we developed some simulations for air conditioning equipment for railway coaches. We were inspired by what is happening in a car where the systems are very well developed. And we observed that with our controllers, the rejection of the oscillations caused by dead times, it was possible. So in the case of another application, ABS braking, this controller, fuzzy self-adaptive interpolative controller, was able to control the sliding of the wheels by precise control actions against the adherence, against the perturbation, with no shocks or oscillations. So it was working in simulation very, very. We have here again some simulations. I hope you can see the figure. So here it's such a fuzzy self-adaptive interpolative controller without adaptation. This is with adaptation. So it is very easy to see that we have some oscillation left side. On the other side, we have no oscillation. We have here auto-adaptive controller. Other oscillation, big oscillations here disappear. And the response of the system, these again big oscillations are this time small oscillation around this point 0. Here it's what is happening for an ABS. So we need this information when the braking is introduced, but because of the sliding of the wheel, the speed that our sensors are showing is this curve, but we are interested in this red curve because this is the real speed or velocity of the car or of the wheel, you can see here. Different simulations when it's a perturbation. So even the perturbation is here, the system is perturbed, but after that, when it's passed, the system is responding well. This is another experience with another perturbation. Now there are some advantages of such controllers. I I will tell you only few. Very fast and easy development, comparing with the uh, conventional controller where we need to do many tuning operations and so on. There are some various adjustments oriented to diverse objective. So we have good performance even in the case of highly nonlinear systems. Such kind of systems can be easy control, make up with our unknown process. So the phase trajectory of the error constituting an observer of the system allow valuing the expert knowledge, because here it's a lot of knowledge that is linguistic side and we can easily introduce efficient implementation and very fast implementation. And I show you also earlier some problems related to hardware implementation. No problem with the FP. Here it's a first application related to the imposed distance method for a system. So this imposed braking distance is a braking action that is following the basic rule that is stop at distance d from here. So the resource of the vehicle, the braking forces, the friction of the disc brake system, the adherence between the wheels and the rail, these are the resources of the vehicle. These are used in an optimistic and optimal, let's say, optimal and smooth manner. So the effort is constantly distributed along the braking distance, not by force, because it's not a comfortable action for a passenger, for someone who is traveling. So the effort is constantly distributing along the braking distance, avoiding unnecessary solicitation and weariness. Fuzzy interpolative position controller is used, and the imposed program is following the natural position. Let's go further. To see here, it's the possibility to follow what we have in this diagram. The controller, it's what I discussed until now, that is the imposed plus position and the actual position. Different coefficient we have here. So the initial velocity coefficient KV and KD is the distance coefficient in order to adapt the mapping to the real initial speed at imposed distance. Then we have here using a program related to knowledge about the system. The controller's task is fundamentally easier in this, any minimal controller can be satisfactory, even a PD1. So related to a position velocity mapping for railway cars, because we have many simulations with real data, and we made this a lot in the factory, even we were not there. Here are some simulations that can show you an emergency brake. So the error you can see there over the time. And here a simulation for a real situation for 10,000 kilograms, the speed of the car, the distance we want to stop, and the time. So it's very important to stop in a certain distance, because trains, when they are circulating, they need to stop in railway stations in good condition and in other situations too. Here it's an ordinary brake. So we have here the force, how is varying the force, how is the error, and how is the position. So you can see even in that slide that we are starting to from zero, how many seconds in maybe 13 seconds we arrive to a position that means 100 meters. How is going, on which law is going uh, our railway coach? It's a kind of a trajectory like here. Here are the other simulations of faster, which are the advantages, the imposed braking distance model. It's an optimal distribution of the braking effort, not to put a big force and to have a big brake. Then we avoiding this ABS, then improved comfort and improved safety. So we have another application here, the optimal distance between two following cars. We need to maintain this distance over, let's say, a sector of a highway, or when we are traveling, we are very much interested to maintain the distance between cars. We are very proud. We launched this application some good years ago, maybe more than 10 years. And we observe that there are many scientists that are using our research and our criteria. You will see soon. And one interesting is they apply to this unmanned car, that's automat cars that will come very soon in our lives. And that principle is there. We need to maintain the distance between two cars. Also, when we discover an obstacle, not to go faster through this, but to maintain somehow a distance and even to brake, because sometimes is an emergency. And you know very well this kind of concept, autonomous intelligent cruise control, collision avoidance systems, advanced driver assistance systems, all that is related to automat driving. There are different concepts, but the key problem in this issue is the control of the distance gap between two following cars. In some papers that we developed earlier, it's a simple measurement method using a CCD camera, as well as a new fuzzy interpolative distance gap control method that is using in constant time to collision criteria. This will follow. So let's see this criterion. The plain fuzzy interpolative distance controller, we consider car 1 and car 2. Car 2 is following car 1 always, and the planned distance gap controller consists of a PD distance controller. So the input variable are the distance gap error epsilon, it's d minus the other quantity between the imposed and the realized distance. The output variable is force, positive for traction and negative for braking. We will see the mapping soon. So this mapping, this surface that is organized by the distance and the velocities, these are two important things here, is adapting the imposed distance to the current velocity of the following car, V2. So we have the car with V1 as velocity. The following car is the car 2 with the velocity V2. If these velocities are completely similar, then they will collide. We have here the same lookup table that we will develop in this situation is the control rules of the distance controller. We are looking to the distance and the change of the distance. or the derivative of the distance. How is the derivative? Is positive, is negative? If it's positive, then the second card will collide the first card. So we put there four terms, four linguistic terms for the distance, and we put five linguistic terms for the change in distance or the derivative of the distance. This is the color. And here it's an interesting law that we discover in the literature, thinking to autonomous intelligent cruise control. It's a concept developed by Google. Also Google developed this automat car, but they introduced there a law um, between the distance and the velocity of the second car, the following car. You can see V2. And this law, it's presented in this formula. What is here? There are some coefficient Z. So there are also velocities. And here they try to simplify the model because here it's a model. And there are many settings, and looking in the practical side, scientists decide that for these coefficients Z0, Z1, Z2, we have some values. So for Z1, we have 0.8 seconds. On the other side, we have 0.6 seconds. So this Z has a dimension of time in this application. There are two objections that can be drawn against this modeling process. So we have no adaptation to the traffic intensity using this formula that we have here in yellow color. So is this one, this formula in yellow to us? So we have no adaptation to the traffic intensity. You must think in terms of how to do, and there are many cars, we need to oblige them to go faster than to make free that component of the highway. So these objectives that we are looking for are no adaptation to the traffic intensity is provided. So if this formula in yellow tune the highest possible traffic, when the traffic is increasing, the following cars will continue to maintain the same short distance gap between them, even there are too many. So in this formula, Z1 and Z2 are artificially introduced. We have no other parameters there, but you remember that I introduced you some models, and I told you we have some parameters. Like for a system, second order system, we have amplification, and then we have the component derivative, integrative, and so on. Looking to the formula, there are some settings, and everyone with his experience will try to adapt this controller to obtain the very good results. So they need to tune somehow. But in this case that I introduced here, the Formula 1, it's very visible that adaptation of the traffic intensity we do not provide. And for this formula to tune for the highest possible traffic, we can do this when the traffic is increasing, so the following cars will continue to maintain the distance. If you put such a controller, they maintain each over the others the distance. So these Z1 and Z2 are artificially introduced here as parameters. Otherwise, we can use from the commerce different possibilities, but the idea here is that this formula that contains Z0, Z1, Z2. These Z are artificially introduced and they have parameters, and that parameters are not used in this case. We will replace this formula 1 is written here. When you will start to see again, you will discover. We will replace by an optimal distance issued by a particular criterion, the constant time to collision. Let's see the criterion. It's very easy to understand. So the time to collision criterion is the time that it takes before car 2 collide with car 1. So assuming unchanged speed of both vehicle, if both vehicle has the same things, then during this time approaching, we have this formula. So time to collision criterion means the distance divided by the difference of velocities between the two cars, following cars. And negative time to collision criterion that we obtain in this formula, very, very easy, but it was made for students to understand. So negative implied that car 1 drives faster, so there is no danger. If the car is faster, then we have another implementation, and we are interested to arrive to this process to maintain the distance between two cars. If we have a positive time to collision criterion, we will obtain another expression, and we can work on them when we will have possibility in MATLAB Simulink. So time to collision criterion lead to the longitudinal driving task and support a set of safety techniques as the intelligent speed adapter is limiting the speed to the prevailing speed limit at the current row situation. So we need to cope carefully here, because in the formula that was introduced earlier, let's go back here, when we will have the two cars with the same velocity, we can see that we have an undetermination because denominator will be 0. This is not okay, and we will try to avoid such activity. How? Doing an inverse of this formula, and we will obtain the inverse time to collision. And from here, the inverse time to collision criterion. Here, we have the annulation of this curve, and for annulation of the denominator, time to collision criterion is presenting frequent commutation from minus to plus infinite. This is the specific process that is happening there. Then why time to collision criteria is often replaced by a trajectory, the distance between the difference in the velocities of the car. So going slowly to the middle of the things, we consider that we have simple formula, very simple formula, and to arrive there, it was important to have the model in your head. So we are interested in have these graphics that means the speed of the car 1 versus the speed of the car 2 and derivate all this. This is suggesting that we can evaluating the collision risk. So we will see such an application again here. Let's go further. There are some simulations for different process. And if we introduce in the beginning a step, how is the system responding? Again, simulations, here this figure, it's very fast to recognize. It is like a butterfly here. But the rules that come out here, it's related to the application here, and with different lines and colors, we introduce a different regime. So with green, that we can see that it's in the middle of the solution. We are all wanted to have, as I told you in the beginning, the error zero and the derivative of the error again zero. So many times people try to obtain these characteristics. So for green characteristics, we preserve the trend. The trend, so keeping with the error and the derivative of the error near zero. If we are in the position of this yellow line, here it means easy brake. So easy brake means that the speed of the car 2 is quite similar, going to be similar to the speed of the car 1. And the last one with red line, it's compulsory hard braking, because the value of the experiment, it's in this way. For the other side, we have another color in violet, no risk at all, any action permitted, can be permitted. So we are very much looking in this direction, not in this one, just to introduce different laws. Again, another situation. And now speaking about the constant time to collision criteria, I told you we are very happy that we discover in literature some applications that are using our criteria. And first we discovered that Renault in France, they introduced this system to maintain the distance between cars, and they obtain 27, even 30% economy in fuel of the car when they put fuel there. Why? Because even in the city, inside the city, not in the highway. Why? Because the driving, it's made very carefully, not to introduce many times brakes and fourth brakes and so on. So they are going uniformly, and the controller is helping to arrive in this control possibility. So the constant time to collision criteria is bringing two advantages: a constant collision risk for each vehicle involved, and the possibility to control the traffic flow on an extended road section. Both are very important. So the risk of the collision is going very down. We are looking for such possibility even for autonomous car. I also propose this criterion that is very easy. So a simple equation is here. I propose also to use them for applications with robots and with the colonies of robots in swarm intelligence, so they can circulate and to try to avoid this collision between different robots. The other one, as I said, on a highway, how to obtain for a sector of a highway to impose a certain distance between two cars, depending on the speed of the cars. If the speed is very high, so we need a bigger distance. If speed is low, we can brake in time. The distance is low in between two cars. I think I have some more time, yes. Speaking also about this criterion, the online control of the time to collision criterion is impossible because of the evolution of the speed of the two cars, car 2 and car 1. Constant time to collision criterion must be implemented offline with the help of some mappings, that means the distance and the velocity of the car 2. So the initial assumption is a distance gap planner built with time to collision criterion, and this all will produce a constant time to collision criterion. So the methods can be applied by computer simulations. We put there all specific parameters, and we had a lot of Here are the two cars, the model in MATLAB Simulink. So backside of this rectangular figure, you will discover other complicated model inside the car, inside the railway coach, because we use the model for different possibilities. Here we can see the PID controller and the time to collision control loop and the imposed time to control system, that we impose a distance, and the simulation. See how is going the simulation. So the evolution of the control time to collision criterion that produce the recorded velocity versus the distance. So for different time to collision, we will have another trajectory. You can see here the time to collision 10, the time to collision about 7, and the time to collision, it's about 5 here. You can see 5, 10, 15. Here it's a comparison between the imposed distance generated by the polynomial model in first figure, this black one, and the other one that are showing the constant time to collision criterion. So it's a big difference between these two lines. And I told you from the beginning that scientists introduce this possibility, that means this polynomial with different coefficients that are that have no any value for professionals, and the response is much better in the case of our constant time to collision criterions. We can see here the same dependence between the speed of the car to the following car and the distance between the cars. So the polynomial is going very, very fast to a plus infinite, while our criterion propose and produce a group of cars. So they are going and maintaining the distance. Here again, I will go faster. For different time to collision that we impose 10 seconds, 7 seconds, 4 seconds, these are made for different distance obtained here. So to maintain and to have this time to stop in 4 seconds means a small distance between cars. Going to 10 seconds, you can see here 40 meters. On the other application, maybe 25 meters. And here, let's say 5, 10, 15 meters. Here is the performance of a constant time to collision criterion compared to a linear map between the velocity of car 2 and the distance. There are some difference in this figure for linear, for P1 and so on. Again, some simulation, other simulation, distance gap is 4, distance gap is 10. We are going on different here. And here it's like a conclusion. So constant time to collision criterion is opening the perspective of adaptation of the traffic flow by means of appropriate time to collision values um, that are imposed by the highway administration to all participants of the traffic according to the driving conditions. So we can impose a smaller time to collision. So in this case, the distance is very small, and a big time to collision, the distance between cars, it's bigger, then the higher will be the traffic flow. If we can impose in such a sector of a highway, we will have a good flow there, and will not arrive to the bottlenecks in the traffic. This procedure is creating a distribution of the time to collision risk of the all automobiles that are going there, circulating there over a platoon. So if 3, 4, 5 cars are going one after to the other and maintain the distance, they are organized in a platoon. There are different methods that can be used here. So we can put such planners the distance between cars and velocity of the car too, and obtain good results. Here is the last application that I want to introduce, maybe faster, because the time is too short. We develop here a fuzzy fusion sensor of the speed of a railway car during the sliding of the wheel, and including a model and an ABS braking equipment. So this was developed by our team, and I was occupied directly with this application, especially for modeling and simulation side, and we start also some practical applications. So the things are going on the same direction, like for cars, when you want to stop and you are using an ABS system during the sliding of the wheel. Here will be the same thing when the braking force is applied. The wheel starts to slide over the rail. And because we need to know which is the velocity of the car or of the of this railway coach, why? To modulate the braking force. We need to know in every moment the velocity of the car or of the railway coach. So here is the definition of the sliding of the wheel, the difference between the velocity of the car and velocity of the wheel. So we have a sensor to obtain the velocity of the wheel, and the velocity of the car we can measure with different possibilities. But to measure the wheel, we need a sensor there to the wheel and to capture that speed. And we are dividing over the speed of the car. So what is happening usually in this industry of railway coaches? If a car or a locomotive starts to have a braking action, if the brake is too hard, as force, the wheel will start to slide over the rail. And if the braking force is applied more and more, that will bring us some damage of the geometry of the wheel. And this fact is not good because always in this industry, in these transportation systems, there are some conditions imposed for locomotive, let's say, even for railway coaches. So always such a locomotive will go to circulate outside only if it is possible that that locomotive to stop in a certain distance when the braking force was applied. If we know the stopping distance, how long it is for every equipment, for every locomotive, and when they are going to be used, they make this probe, and if the locomotive is not stopping in this certain distance, they will ask to go back and to see their wheel that are not completely like a circle, that they have some different shapes, and this shape can cause not to stop in a certain distance from here. So the formula of the sliding of the wheel is here. So sliding, it's a parameter that it's very hard to measure. So we can only estimate. How to estimate the sliding? It's impossible because we need the velocity of the car, velocity of the wheel. When the braking force is very hard, the sensor of the wheel is not giving any information because the wheel, it's completely blocked and it's sliding over the rail. At the same time, the car or the railway coach has a speed. Even the speed captured from the sensor, it's 0. And we need this velocity of the car when it's blocked, the braking system. So let's follow. For this mapping, we can see the mapping V-car for 200 kilometers per hour. And for having an efficient ABS system, we need to be in this side of the graphic. So how to choose slack of the wheel or sliding? I told you we can only estimate, or using this graphic, we can have our model that will tell us where we are in this interval. So for the beginning, we are in this interval. When the friction is enough, we will be there. When the wheel will start sliding over the rail, we will be in another position. So the most efficient braking system is when the sliding is in this, only in this region. When it's in this region, we will have a braking system very efficient, even for this kind of railway. Here it's a figure where you can observe to every wheel we will have a sensor. And if we will start the braking process, every wheel will have another speed because some of them will receive a little big braking force. The reality is here. So every wheel will have a speed, and we will be interested in collecting the maximum of this speed. The maximum of this speed because we want to arrive very near to the curve, that means the velocity of the car. So we are interested in maximum of these curves because in this position, they are very near to the velocity of the car that we can also measure with different methods. But usually the speed of the car is taken from the speedometer that is proposed to that side that is a wheel. So we know every this variation, but this variation we don't know only by interpolating we can arrive to it. Let's go further. So here it's a solution, the evaluation of this sliding. And disadvantage is the accumulation of the error because we are working with such MATLAB Simulink and is there accumulation of the error. Why? Because in MATLAB Simulink we are working the backside of what we can see over the computer. We can see that we have a difference between this velocity and the velocity of the car that we need to have after that pause. Here it's an idea that was introduced by those working in the automobile industry. So to arrive to perfect information related to the speed, because this is very important for such system, we can have an information about speed using an accelerometer. And what to do? We will integrate the accelerometer, so this value, and we will obtain the velocity of the car. This is very easy to organize. It is true, it's a little bit costly because we need to put such an accelerometer as an equipment for the railway coach. It's a paper where they study such effect, and the precision of an accelerometer integrator may be critical at low acceleration because of the noise and of the offset of that application. The first stage is computing the trust degree of each of the 4 speed sensors. So we need to have confidence in a specialist or in a tool then to let him control everything. The second stage is computing the trust degree of the accelerometer. So for the velocity of the car, we will have an estimator that divides the operating regime in 3 different domains. Deceleration is ground, then deceleration is 0. And again, looking to these rules that we are introducing here, let's see some of them. So we are this time some estimator. So the estimator divides the operating regime into 3 domains. So deceleration is great. The weight of the speed sensor is small. Then deceleration is great. The weight of the rear traction wheel is large. They are most probable. So different rules that we are introducing, and we try to arrive to this world knowledge introduced by Lotfizadeh. Every one of you are a small engineer, a small specialist, and you can solve different. We have here a new item that is a deterministic computer of the ABS system equipment of the railway coach. So the model, looking to that paper that was presented in Budapest in 2006, it's related to Budapest. Um, it's related to the model of the sliding wheel during the break. We presented in a conference in Budapest, as I said, in 2001, and the model includes the nonlinear differential equation of the sliding wheel and the whole moving vehicle. We will produce a model of the different component of the railway coach using the real data because we have at that time. And we are looking at the braking equipment to work very well. So the brake equipment parameters, that means dimensions of the cylinder of the steering gear and the brake disc, the friction coefficient of the brake disc, these are many parameters that we are interested to know. The model could be corrected and very easy, directed towards different objectives. So it's possible the application of this model, and the application is that of an evaluator of the speed of a possible answer to all these challenges rely to the interaction of accelerometer on the computer model of the brake. So introducing an accelerometer here, we will have a clear information related to velocity. But how? By integration. By integration, we can introduce also some errors. But let's think that errors are not so big, and to act thinking that we have good information. Velocity of the car is now the output of the model. And the beginning of the sliding is detected when with the help of deceleration of the wheel. So we will obtain not a good information related to the velocity of the cars if we are using the first criterion. The second is here. And slowly we will go to that application that want to obtain the clear velocity of the car or the velocity of the railway coach, in our case, using a fuzzy fusion block here. So which are the possibility to collect the velocity of the wheel? There are many possibilities. Collecting the velocity of the wheel and then to arrive to the velocity of the car. Why? Because during the braking process, these velocities are different. So the first possibility is to take, let's say a car has 4 wheels. Let's say a railway coach has four wheels. In fact, they have maybe double as number or again double. Why? For stability. So if we will collect the information for every wheel and we will try to find the maximum of these velocities, we will arrive to know that one system is close to our system. And we are interested to conduct this specific tool during a practical application. So first we introduce the 4 wheels, and if we will take the maximum it's very near to that line that we printed earlier. So this is the first possibility. The second possibility is like in this figure, you can see that we arrive with A, that means accelerometer, the signal from accelerometer. What I am doing with the accelerometer, I can integrate, and in that moment I obtain the real data online, exactly online. We have the possibility to measure this um, velocity. So accelerometer plus integration gives us this figure. Here it's also good that we can estimate the adherence. We can evaluate, estimate. That it's wonderful because we need to know. But if we will say to the specialist that was presenting this topic, I saw a few days ago, if we are looking to him and to all that he's discussing, we will arrive very fast to a solution for our systems. If you are going with the second solution, this one can be a long time. So coming back, we obtain information saying which is the maximum information that I am acquiring now from the all wheels. This suppose that every wheel has an accelerometer. Then I have the accelerometer himself that is introduced into an integrative block. And at the end, we have the same relations. That means the possibility to measure the adherence. And also we have in this figure the computer model. I told you that we will know much more if we will be able to organize the computer model of that process. So using the information from the cylinder pressure that is introducing in the computer model, that will give us a new velocity. The second velocity is the integration of the velocity, because we know very easy. So integration of the accelerometer means velocity. Integration of the velocity means distance. So this accelerometer can help us to have the acceleration of the system that can tell us many things. If we will feel acceleration, so going faster in one direction, we know that is because of the technology around us, because of a system that is breaking, or we do not have bread, so no possibility to measure, and so on. So the applications that I propose here was to collect different information from the wheel, from the accelerometer, and also a combined idea that means an adaptive strategy using all these aspects. What is important also, having this information, we introduce information in the fuzzy fusion block. It's like a switcher here, and we will obtain at the end the speed of the car. Too many possibilities and explanation. Here we have the same block I told you earlier. They decided to publish, and they will arrive very soon with this block diagram that we have here. It's important here to introduce, let's see, cylinder pressure. Also, we can estimate the concept of acceleration. And here we have the measure introduced from the accelerometer. So using an accelerometer means some money plus there. So another investment, but we will have a certain velocity that is very near to the real one. Of course, we have the computer model here. I told you, control using the computer model, it's very, very useful in many situations. Here we have some simulation again, different block in organizing railway coach. So we have actual analysis. We have these two applications on our secretary computers. Why? Because they need also to see what is happening with that car, with that railway coach, and if they use material from there, if they improve their systems, and so on. Um, it seems I stop. No, I continue, of course, with some simulations. You can see here in this figure the railway coach, the model that stay backside of this figure. At the entrance, we put some real data. You can see the weight, it's 40,000 40,000 kilograms. Then we have an initial velocity that we can introduce, and other blocks on this figure related to the railway wheel, even the model. The information are going to the car. Then we have another implementation. What is nice here, we can estimate F. Who is F? F is the inverse of the estimation that we introduced. And putting there something to measure, we will have a value and we will know where we are with our research. Different simulation for the body of the railway coach, and then here the bogie. Then we have the blocks that are standing under these blocks. There are more complicated blocks, and here it's a figure when we put the fuzzy fusion block, because I told you fuzzy fusion self-adapting interpolative controller. So we complicated a little bit, but not too much. And we are using a fuzzy controller, not a conventional one. Why we are using like this? Because there are some prototypes in some factories, and we need to do it and to have some measurements on him. Or we produce only few, and using such model, we will allow the system to have the best information that can be collected. A simulation control and simulation conditions, I put again on a value this computer, and there are some simulation conditions. The accelerometer is affected by the online lines, and if you put even some noise power, we will introduce some perturbation here to the system. You can see the power noise, how big is, and also other possibilities. We have an offset signal that can be introduced from the accelerometer, and the first order delay element that it is to be added to the accelerometer. The first order delay element was added to the accelerometer model. And the output of the model M1 and M2, that means estimated velocity and adherence, are delayed with a certain time. Here are simulations, let's see. We have here the possibility to estimate the adherence. You can see that is happening during when the system is passing from one to another value or coming back. It's the possibility to develop diabetes. Let's go. Other simulations related to the speed of the railway coach, as I told you, if it's their braking process, we can try to use always to have in our house such devices. So there are differences between the reality of and the model, what the model is giving, and we try to have um, as much as close the information that is given will. Here are some details related to the fuzzy development of this solution. So fuzzy fusion technique is a fundamental solution that it's very easy to develop because we are working with linguistic terms. We are not using a certain number. We are using with big, bigger, small, smaller, and so on. The outcome reflects the contribution of each entry of the fuzzy fusion structure that I was introduced you. And in our case, we dispose different evaluators of the must to be aggregating in a single evaluation. So the fuzzy algorithm that compute the confidence degree of each entry plays an important role. To every velocity that we will have, we will obtain a certain value that we can offer a degree of confidence. So when the speed is very high and of the vehicle and we want to brake, we will obtain an information with a low confidence degree from the sensor of the wheel. Why? Because they start to slide over the wheel. And as I said, we will give a confidence degree for every entry that is playing there. When the velocity is very high, the information that is very near to the reality will be the information for the accelerometer, because the accelerometer can give us the best information when the wheel start to slide. Then we have when the velocity is very low, we can have the confidence degree very high for the speedometer that we organize from every wheel. So this is again a good idea to introduce this confidence degree for each entry. The tuning point of the design of the algorithm is the choice of the input a priori information that will be encrypted in every rule. So we will have some rules we will follow to understand. In the example that we will develop here, we assimilate the fuzzy fusion algorithm to multiple inputs, multiple outputs, fuzzy controller in the sense of a fuzzification. So we have fuzzy inference defuzzification entity we will have there. This structure can be equaled with an interpolative algorithm that it's at its turn may be implemented in n-dimensional lookup table with linear interpolation. We made such a small project, and there are nice results. Here are some rules, specific rules. So the first rule, rule number 1, if the sliding is 0, so the wheel is not sliding over the rail. S is 0, then the information of the wheel is great. So that means the wheel is not sliding. I can take the information from the sensors that capture the speed of the wheel, so the information from the wheel is great, and the information from the accelerometer is 0, because we do not need accelerometer in that area. And also the information, so the degree of confidence degree of the model is 0. And we do not need a model. For us, is sufficient the information from the wheel. If the slide it's not 0, so the wheel start to slide, and the derivative of this is great, so showing that we'll start the wheel to slide over the wheel, then the degree of wheel is 0. What we capture from the wheel, that sensor from the wheel, it's 0, and what we capture from the accelerometer is great, and from the model is small. So we have these three sources, and we have, if the slide is small and the derivative of this sliding is small, then what we capture from the wheel, it's 0, it's not good. And from the accelerometer is small, but what we capture from the model, it's great. So we introduce some fuzzy evaluation in this case. The implementation is very easy by the help of this interpolative lookup table, you can see here. And an example can be seen here, the resulting for the degree of confidence of the accelerometer. So the accelerometer that is used when we have braking action very strong. We will use the information from the accelerometer. Then as conclusion, we have here, we develop such device, such a sensor, fuzzy fusion sensor. So this sensor is giving us an information that is providing from different sources, and we fuse this information. From one source, we put with the confidence degree 0, another source has a confidence degree, let's say 1.3, another source has the confidence degree 1.7, and we fuse all this information to obtain a very concrete and good information related to the speed of that car or of that railway coach. So the resulting data processing platform constitutes a flexible approach for instrumentation of the different control strategies. The precision of the estimation is growing by selecting the more trustable device. You observe that even we cannot estimate we cannot measure the sliding that S, we can estimate. So even we have a sensor that can give us an information related to this. The rising of the redundancy by increasing the number of different sources of information induce a better reliability for the system. So different strategies and validation can become possible. The resulting real-time evaluation of the rail wheel friction coefficient can improve the adaptive capability of the railway coach. And this approach represents a step forward towards the development of a new generation of such ABS controllers operating by means of a wheel sliding control loop. So different. And thank you very much for your attention. It was a long presentation, and there are many applications related to this possibility of control such systems. And we have other applications in control the temperature in a room, control the temperature in a greenhouse. We have such a nice application, and more recently in a new concept of the top green roof houses. That is everything green there, and use the circulation of the air, from inside the building, and many other applications where we have highly nonlinear systems we can control without any problem. So thank you once again. And if there are questions, or if you want to see our applications, our technical development, you can follow our papers on ResearchGate, on any other platform. Thank you.
Thank you, ma'am, for your wonderful talk. So it's really a very wonderful talk. So any delegate, if any delegate is having any query, then you please ask the query from the ma'am.
Maybe I can see in the chat. Yes, I will open to see.
Yeah, you can also post your queries in the chat section. Okay, then thank you, ma'am. Thank you very much for your very wonderful talk. So next for the invited talk, we have eminent professor, Dr. Jenkin Weinstein. So before inviting Dr. Weinstein, so I would like to introduce. So Dr. Weinstein received his master degree in communication engineering from BIT University, and currently he is working as an assistant professor in the Department of Electronic and Communication Engineering, Karunya University, India. His research interests include biometrics, pattern recognition, computer vision, and machine learning. He has numerous publications in the national and international journals of reputation in the computer vision, machine learning, etc. He is also an active member of International Association of Engineers, Hong Kong. So I would like to invite Professor Dr. Jenkin Weinstein for the invited talk. So over the mic to Dr. Weinstein. So please.
Yeah, thank you, Mukesh. Is my slide visible?
Yes, sir. It is visible, sir.
Yes, sir.
Yeah, thank you. I know we are almost time. We have again some few minutes I'll take. I'll take some around 15 to 20 minutes so that we can actually start up with the rest of the sessions without any delay. And this is our campus here in Coimbatore, Tamil Nadu, the southern part of India. The lush green, this place we even love now under lockdown to visit, to stay on on current trends, to do some research works, and for teaching, and for other meetings we still visit our campus. And if in case you have some time, you can visit our campus in later stage. And without further ado, I'll start with my presentation. And here we will be seeing about biometrics, which can act as a virtual gateway. And we'll start with some basic ANN approach and how to take up as a researcher. I see some young researchers there. So those who are there to looking for taking up some research work, contributing some improvements in their existing models. Okay, very well. This presentation would be a useful one. I believe. And I also thank the organizer, Dr. Mehar Chand, and the principal, Pradeep Kaura, for making up all the efforts in bringing up all the dignitaries across the globe and taking up this stage into a virtual platform and making this happen on time without any flaws. And I also wish the entire team much more success in coming events as well. Yeah, so biometrics. To start up with the biometrics, it is actually the measurements which actually possessed by a human being, and it can be either a physiological characteristic, either the physics, the physical appearance, how they look in their body, that can be actually taken as a biometric feature, or the way in which they interact with their gadgets, or the way in which they walk around, and the way in which they interact with people around, okay, their thinking patterns, the behavior patterns, that can also be actually taken as a biometrics in the field of giving attention or giving permission to access any important documents. And this is these informations like the physical things as well as the other parameters can be captured in digital forms, okay, and they can actually act as a digital ID, and it can act as a key stopping point whether to grant access or not to your personal electronic gadgets or your financial transactions, or you want to access your online store network status, any sort of kind of access you want to grant, that can be done at this stopping point by verifying this biometrics. And we find these applications widely used across the globe, and I think this would improve further with this coming pandemic scenarios. There are some security issues across the globe which are raising concerns to provide access or prevent access or constrained access to critical laboratories, okay, or some important buildings, some land sites, or even crossing across the border. We will be needing some biometrics to actually monitor this people who are crossing across. And why do we need biometrics? And instead place of the previous one-time passwords we have, and the other what to say, like we have the passwords in the earlier systems, some punch code systems are there, you have the credit card systems. So why do we need biometrics? In the sense, we need a secure system. Here we need the physical presence. We cannot exchange the password with other person. We need our physical presence. So that improves the security of this particular automated recognition systems. And one more thing, it can also avoid the burden of keeping in memory the passwords which we have to give for access. And the other motivation we can see in the market, there is an increasing revenue that is expected around $69.8 billion by 2025, an annual growth of they're expecting around 22.9, because each electronic gadget that is pumping up into this world, they are trying to integrate it with one or the other biometric systems. We can see that latest smartphones and other even our laptops, other scanning devices are coming up with this biometric systems and being rolled out into this retail stores. And coming into the modalities or the modes in which these particular features are being taken, like we said, physiological and behavioral patterns. We have physiological means the appearances and the things which are confined with the human itself. That is the face, fingerprint, hand, iris, and DNA, and much more are there, like your veins of your palm and the other things which we can take and we can work on. And behavioral things like how we stroke our key pads and how we sign our signatures on digital pads or any other thing, and the way we actually have our pitch of your voice, those things can also be taken and can be actually think. Okay, and there are numerous data sets which are globally available at free of cost. We have to write up some request letters or some forms. We can fill it up and give, and we have to give in some recognition for them, and so that they can provide us the database for actually to work upon. And this is about the milestones that were achieved from the fingerprint recognition. Lately, that automated fingerprint identification systems, and lately we can see India in recent past using this universal ID number, that is the Aadhaar number, 12-digit number they are given with the help of numerous biometrics. Not only the eyes, they've taken the palms, okay, they've taken the retinal scans, and they're trying to have a multimodal kind of recognition. Even with one thing, we can achieve, even with one biometric trait, we can achieve much recognition. And the recent development with smartphones being enabled with several GPUs, okay, and they are having even faster okay, the tap to pay two-factor authentication method was there. And I think this will actually even the mobile pay things which actually coming up in recent trends after the innovation of UPI. I think this will actually even more move forward with the integration of biometrics with the UPI systems. And again, the digital camera systems, we have several developments over the years, right from starting from the pinhole camera and the recent digital cameras, the wearable cameras that are coming up, and the contributions of several eminent scientists in the over the years from 1964, where they first started up with the automated face recognition systems. And then the key phenomenal milestone was the alien face and the binary patterns, which was there, and the Viola-Jones method. And the recent boom in the neural network field are actually all contributing much more. And we can see these are all taking up the biometric system to the next levels. And to choose a biometric trait, we actually see in this paper quoted in 2004, there are different things to note, like you have this university availability should be there. Every person should have the trait, and people should be acceptable to use that trait. So on that factors, if we choose, we can see this iris, which is more safe and secure to handle and work upon thing. But still some challenges are there. We have so constrained things to capture the iris from a camera. We have to do that segmentation process. We have to look into, we have to track the eye to take the segmentation, and some constraints are there. And if we are able to do that, I think with some ultra high definition systems and some tracking methods, we can very well capture the track the iris, and we can actually proceed further with segmenting the iris part. And this is one good data set, which is from our own India, where we have from IIT Delhi. We have a number, we have around 2000 images around in this data set, where we have some different deformations are there, like blurring is there. They have some corrective lenses are there, some fashioned lenses are there. Okay, sometimes the eyelids gets closed. So I think to start up this particular data set would be a very good one to start up. And coming to the whole overview of the system, we have to take the data images from the data set, put up some enhancing method, and segment the iris region. Here they are trying to do it into a normalized fashion, because the exposure of light to the iris would actually may dilate, or sometime over any nervous situation, that eye pupil of the iris can actually become so curious, and they become elongated, or sometimes they become so narrow, and they can change the shape of this particular region. So we can actually try to fix it into a fixed block size like this, and then we can try to grab some features. I have tried to take up some moment-based features. Around 7 different features I've taken, and I've given it to the neural network to train. Okay, and any neural network can do with this once you're taken up with the features. But there are some advantages and disadvantages when we have around thousands of employees in a company, and we want to monitor, or we want to give access to them, and you have that much amount of data and give it to a neural network to train and look around all those things. The fastness in which we actually give access also matters. So it is better we actually take up a simpler network and empower its efficiency in multiple phases, like recognition or the speed to give recognition rate. So like that, we can actually think about and actually work upon. So the best solution would be the ANN. I'm just going up a little fast. Coherent network is actually a simple network where we have a single input layer and a single output layer. And the biggest thing is the way in which actually this works is we feed in the input features. One of the neurons in the output layer would get excited, and that defines that particular input feature which is coming in belongs to that particular class or that particular person out of the n different persons we have. And to train this network, there is a method we follow. First, we find out of the n nodes which is more similar to the input feature which is coming, and only the weights associated with that particular similar node or the winning node we say that is actually updated using the rule, using the 0.4 which I've updated. But when we go for this coherent network, these are actually unsupervised network. When we go for implementing this particular unsupervised networks in real scenarios, the classification accuracy is very, very little because of the lack of supervision. Okay, and there are some randomness to when we try to find the matching process, like similarity measure. We try to take the distance between the input feature vector and the weights associated with each of the output nodes. So when we try to take that things and try to update the weights, there are some chances of jumping into the other classes to which it doesn't belong. So there is some jitters when we actually start up the training process. So to avoid this, we can actually try to update the weights as carefully as we can, so that it doesn't goes into the random state of updating. It stays very well confined within the actual node it has to actually start up with. So we can actually think about like that fashion, and we can actually go upon with it. We can try to have some grouping mechanisms and we can work upon. So instead of choosing this weights directly, which is given by the method, we can actually go for some optimization methods. So I have taken up some this global, that is gravity search optimization, and the teacher learning process. We actually look into the nature and we can learn a lot. And there is a bit of mathematics involved in it, but employing all these equations, I can actually give it as an example. Those who are working anywhere, you actually have this kind of weight factors involved in your network to give in better results, or some cost function is involved. You can actually look in for this kind of optimization method, nature inspired optimization techniques, where you can actually put in your existing networks, neural networks, and find out how this actually works. And there is one of this beautiful networks method, optimization method. We call it as gray wolf optimization method. Instead of having one person's suggestion for a better solution, we have a group of like 3 different groups are there, like alpha, beta, and gamma. So all these 3 persons understanding towards the better solution we can actually take in, and we can actually proceed to give in the better solutions for our network. And you can say about this confusion matrix, and then we can analyze the performances of this particular methods. And out of all the methods I have actually gone through, I have achieved a very, you can actually see that this particular method, that is the second method with gray wolf optimization, was able to achieve 99% of accuracy. And this was very well more improved when compared to the other methods, like the existing self-organizing neural network that was around 83. And coming to the deep neural networks, I think without deep neural networks, we won't be able to confine much of the research happening in the later recent times. And convolutional neural network is a very good network to start up with. You can actually design your own network. And here in our network, we have actually learned several convolutional filters. And you can see these are the filter results of convolutional layers. And these are the results of the image after getting filtered out through those filters, convolved through those filters. So after convolution and after batch normalization and after activation, and then we are actually getting a result around 96.43 with the learning methods. You have different learning methods. For want of time, I'm actually stopping out now. So as a researcher, any yearly researcher, you can actually take up any problem in this biometric field. There are some challenges in segmentation, classification. Sometimes if someone else is actually showing up a digital video in place of his own presence, how do we actually spoof detect it? So those kind of things can be taken. Do some research, take up some possible changes. You can do it for the existing methods, and then you can actually simulate your results. Then you will be in a position to publish in good journals. And at any point in time, you can actually contact with the organizers. I would be feeling free to help you out in any regard. Either you can choose MATLAB or any Python open sources now available. And even you need not have the use of GPUs. You have the Google Colab to work on and start up your research work. Okay, so thank you so much for paying attention. I hope it would be of some sense for the listeners. And I hand over now to the organizers to proceed.
Thank you, sir. Thank you for your wonderful talk. So I'll now request to the delegates, if there is any query, then you can ask from the Weinstein sir, or otherwise we are proceeding toward the paper presentations. All the delegates can also post their queries in the chat section as well. So if there is any query, then you can ask. Okay, so now we are moving toward a paper presentation session. So first I am requesting all the delegates, you please conclude your presentations within 10 minutes so that we can also start our next session on time. So there are 4 presentations in this session. And first I am telling the order in which the presentation will be done. So first presentation will be by the Mr. Dande Lokeshwara Reddy. After that, the presentation will be by Deepa Devarajan. And then the presentation will be by Himanshi Rajput. And last, the presentation will be made by Janmaya Kumar Mishra. So again, I am requesting all the delegates, please conclude their presentation within maximum of 10 minutes. So now I am calling first presenter for their presentation, Mr. Dande Lokeshwara Reddy, for their paper. And the title of his paper is Big Data Security and Privacy Issue in Healthcare Using Big Data. So handing over the mic to Mr. Dande Lokeshwara Reddy.
Good afternoon, everyone. Am I audible to you, everyone?
Yes, sir, you are
Hello.
audible. Yes, sir, you are audible. You
Uh,
can proceed with your presentation.
Thank you, everyone, for giving me this opportunity. Now I am starting with my presentation. My presentation is about security and privacy issues on big data, on healthcare using big data.
Yeah, Kumar, can we have your slide shared on screen? Janmaya.
Sir, a slide is not visible.
Yes, sir. 1 minute, sir. I think it's network issue. 1 minute.
Okay, fine.
Sir, it's showing host disabled participant screen sharing. It's showing like that.
Yeah, I think they will add you as a co-host so that you can share.
Sir, if you are facing some issue, then you can present your paper at the end. So for the meantime, we can call to the next presenter. Or otherwise, if you are, you can share, then you can share also.
Yes, sir.
Okay, okay. Now your screen is visible.
Yeah, I can go ahead.
I sorry everyone. My PowerPoint is I am unable to present my PowerPoint, so I'm starting with I'm presenting with my publication paper. My paper is about big data security and privacy issues on healthcare using big data. We all know the healthcare nowadays in healthcare, every document is now automatically using online documents such as patient files. In previous times, you have files such as on papers, but nowadays it's all based on online. Due to this, we also have lot of data that is gathering in healthcare. So for this kind of problems, we are using big data as a solution. Now you can see with increasing healthcare and healthcare insurance premiums and also a lot of patient files. So we are using big data. Now current to find healthy, flexible and systems on of electronic records of patients. There is a lot of data and there is also emerging lot of emerging lot of problems such as hacking, misplacements of data, and also the loss of patient files. For this problem, we need privacy and security of the patients. You can see there is a holistic model of the healthcare. Now we have various branches in healthcare like clinical, social, physical, enrollment, and psychology. Like many patients have different kinds of health issues on different kind of records on the health on this. So every patient needs a different kind of privacy, such as some people need identity privacy, some need a record privacy, and also various privacies. We can also have you can see there is a related works on the on where various it's not first time many scientists did the related works on the healthcare issues like and see there is a NHS Foundation Trust in southern side also worked on this health issues. Based on the various research, they invented uh, whereas they say we need to have various benefits under normalization risks of big data. they need policies which can ensure privacy and security issues. Like you can see their policy attention to focus on more on actual use of big data and less collection and analysis. Policy concerns
Dante,
privacy.
Dante, can you actually go to the work and give your works explained?
Yes, sir.
Yeah, can you go to the work or the model you have taken?
Yes,
Or
sir. Like actually, a model I'm working on based on collection of various big various data and using Hadoop and other all this. Actually, we are on a starting stage of work. So it's mainly of a kind of theoretical
okay,
paper.
so this is actually a survey one.
Yes, sir. Like a kind of survey one.
Okay, so what are things you are finding as challenges in the data healthcare or the digital healthcare services?
Sir, mainly we are finding a data such as information loss or information misplacement. Also, some kind of external grabbing of information without consent of patients. Like we can also have popular figures. They're unable to show their records, but there is a actual loss of hacking and also misplacement, which may public humiliation to some of them. So we are working on how to make a their privacy and security more authorized and more authenticated to the patients and users.
Okay, so you are then working, you have done that two crucial problems are information loss and security, right?
Yes, security, yes, sir.
Yeah, so, yeah.
And also you can see there is a we can apply this apply various methods such as authentication, encryption. Also you can apply data masking. Data masking is a kind of process which will cover the original data of by random data, so we do not need to fear the original data will be compromised, because data masking will cover the original data. So even if outer sources will try to find information, it will be bounced back of not finding the original data of the page users. Based on the privacy and security issues, there are various laws implemented by the various countries in a way, such as you can see here. There are various laws protected in various countries, data protecting laws, such as in USA there is HIPAA, and in EU there is a data uh, DPD, and you can see in India also. In India also we have a law of IT Act and uh, IT Anonymous Act. So in by these are in privacy and security issues, they should follow the these policies of those countries to ensure the security and privacy of the users. Also, there is in my research I have found that various privacy protecting analysis, such as you can see there is a privacy protection method such as anonymity, de-identification. De-identification is a kind of a way to preventing disclosure of confidential information in disclosure of any information to patient unless the patient have the specific patient identifiers. I also have there is various techniques in this is anonymity, diversity, closeness, and HybridX. HybridX is a kind of model for confidentiality computing. It is public kind of only for an organization, usually computer classified as public. I also have we can see anonymity and diversity is a form of group analyzation ability to safeguard the data set by the users. Is a more is a overall picture of the how the it works for exclusive categories for hybrid and this model format is you can see in picture. Is a overall we can conclusion that we have various methods, and also we need to improve various methods to say ensure the privacy and security and big data. Yes, thank you.
Okay. So is there any IoT protocol you are taking up to? Is there any IoT protocol you have looked upon for getting up this big data?
Sir, actually, I'm researching on various IT protocols. Sir. Actually, I'm working on Hadoop, how to gather data. No, I will be working on improving the analytics and various analysis on these papers.
Okay, so you are working about analytics
Yes, sir.
of the health records.
Yes, sir.
Okay. Okay, Dante, you can proceed. Yeah, Professor Upinder, you have any questions? I think you can.
No question, sir.
Yeah,
Okay, thank you, sir. Thank you, ma'am.
yeah, thank you. Thank you.
Okay, then we are next inviting for the next paper by Deepa Devarajan, and her paper is DOS and DDoS attack detection using machine learning algorithm. So, ma'am, you can please unmute yourself.
Yes, thank you. Thank you everyone for providing me this opportunity. So I have written a review paper on DOS and DDoS attacks. I'm not able to share my screen.
Ma'am, just wait for 1 minute. We are providing the right to share the screen.
Okay, sure.
Yes, ma'am. Now you can share your screen.
Okay, thank you. So what are DDoS attacks or DOS attacks? Denial of service attack or DOS attack is meant to shut down a machine or a network, making it inaccessible to legitimate users. A DDoS attack or distributed denial of service attack is a class of DOS attack wherein there are multiple attack sources. The attacker compromises multiple systems, and these systems, also known as zombie systems, are then used to launch simultaneous DOS attacks, thus leading to temporary shutdown or crash of the server. Sometimes such attacks also involve IP spoofing, which modifies the source IP address, making such attacks even more difficult to identify. There are several types of DDoS attacks. Broadly, they can be classified as volume-based attacks. These type of attacks include UDP floods, ICMP floods, and other spoof packet floods. The goal of such attacks is to saturate the entire bandwidth of the attack site. Another type of DDoS attacks are protocol attacks. These attacks include SYN flood attacks, fragmented packet attacks, etc. This type of attack consumes actual server resources or those of intermediate communication devices, such as firewalls and load balancers. Application layer attacks include low and slow attacks, get or post floods, attacks that target Apache, Windows, or OpenBSD vulnerabilities, and more. Such attacks are categorized by this innocent packet requests. However, they are aimed at crashing the web server. The major motivation behind DDoS attacks, as viewed from an attacker's perspective, could be ideological differences that can cause DDoS attacks. The so-called hacktivists who are protesting against websites they disagree with ideologically, or it could be due to business rivalry. The businesses trying to strategically take down competitor websites. for instance, by preventing them to participate in significant events. Another reason could be extortion, wherein the perpetrators use DDoS attacks or a threat for DDoS attacks as a means of extorting money. Government authorized DDoS attacks, which can be included in cyber warfare, it could be used to cripple opposition websites and an enemy country's infrastructure. So moving on to the trend of DDoS attacks. The first known DDoS attack, known as the Panics, it occurred in 1996. It was one of the oldest internet service providers, which was knocked offline for several days by a SYN flood attack, which has now become a classic DDoS attack. Over the next few years, DDoS attacks become common, and according to the annual Cisco report, the total number of DDoS attacks will double from 7.9 million seen in 2018 to something over 15 million by the year 2023. But it's not just the number of DDoS attacks that are increasing. The attackers are creating ever bigger botnets, the armies of hacked devices that are used to generate DDoS traffic. As the botnets get bigger, the scale of DDoS attacks is also increasing. A DDoS attack of 1 gigabit per second is enough to knock down most organizations off the internet. However, today we are seeing peak attack sizes of almost around 1 terabit per second, generated by hundreds of thousands or even millions of stubborn devices. In my literature review, the common types of detection systems for detecting DDoS attacks are as follows: using the SVM classifier, KNN, naive-based, ensemble methods, and hybrid methods. Ensemble and hybrid methods have shown promising results. Ensemble methods combine several base models in order to produce one optimal predictive model. An example of an ensemble model could be random forest, which is used to combine several decision trees, hypothesis of several decision trees, and used to predict the final output. Hybrid methods combine two different models. Example, a hybrid model can have an unsupervised learner to pre-process the data and one supervised learner to learn the clustering result. Some of the features that could be used to differentiate normal traffic from DDoS traffic are as follows: the number of HTTP counts. In order to cause a DOS or DDoS attack, the attacker needs to have at least 15 to 20 HTTP get or post requests per IP address. Number of IP addresses accessing the server at a short period of time. Usually, a person spends some time reading a website or going through it for some time. A botnet or a zombie system just sends multiple requests accessing several URLs. Thus, in a short span of time, we can observe that there are multiple IPs accessing the same server. Some of the research gaps that I found in my study are there is a trade-off between accuracy and training time. Some models tend to have a very high accuracy, but take a long time for training. Some other detection models take most of the features while training the model, which makes the overall detection system complex. This could be further prevented by applying a feature selection algorithm. Also, most of the models focus on detecting only one or two types of attacks. Thus, they can be made more scalable by training them to detect multiple classes of attacks. That's all from my side. Thank you.
Yeah, thank you for your presentation, Deepa. Like you are setting some models you are going to see, whether you are going to work on those models like some SVM, you have said ensemble models are there.
Yes, sir.
So,
In my further study, I have selected a base paper wherein they are using an ensemble method. The overall accuracy of the model right now is 99.1%. I intend to apply a feature selection algorithm on it to further improve the accuracy and reduce the training time at the same time.
okay, so that's good. How would you actually, what are the features that you would be actually feeding into your ensemble network?
So some of the features that I had mentioned could be the rate of IP addresses in a short span of time,
Okay.
and the number of HTTP count or IP addresses that are used per that is used per IP. The number of requests made per IP address.
Okay, that's good. Yeah, any other feature you're having, or just the two alone?
I don't have anything else right now in mind.
Yeah, you can actually try to go through some of the other features.
Okay.
As you said, the number of requests that ICMP is actually making in that time,
Yeah.
that is a good thing. And apart from that, if you have any more, like more number of features you given, that study you can make it. Because since you are actually trying to go for feature selection,
Yes.
the need for feature selection comes only you have a large number of features and what is the best to choose.
Yeah.
Okay, so it is better you know, even do so much little more search on that, and then you can proceed.
Okay, sir.
Yeah, thank you, Deepa.
Thank you.
Yeah, thank you.
Thank you, Deepa. Now I will request to Himanshi Rajput for next presentation. Himanshi Rajput.
Yes, ma'am. Thank you, ma'am.
Welcome. Yes, ma'am, you can continue.
Ma'am, I'm not able to share my screen.
मैम होस्ट बना दो होस्ट
Now you can share your screen. Now you are host. Himanshi Rajput, unmute yourself. Himanshi.
Sorry for the delay. Is it visible?
Yes, your screen is visible. Now you can start, Himanshi. Best of luck, Himanshi.
Good afternoon, everyone. So, okay. So my topic of study was is like plant disease recognition and classification using image processing and deep learning. Image processing is also the required part before applying deep learning models. So, first of all, I want to present the reason why I would like to consider this topic. So, as have gone in the statistics, like there were a lot of time in various previous year, there were a lot of loss faced by the farmers because of the diseased plant and has directly lead to the economic loss. So like I have one data in 2018 crop disease post 3 years to lemon and orange trees. This I have read in article written in Reuters. So like farmers had 135 acre of land, and with because of infected crops, 40,000 lemon and orange trees were produced in small in size and were bitter in taste, because of which the market value of it decreased and led to economic loss as well as scarcity of lemon and fruit in that region. So disease is like we need to study. Before it was like traditional way to look into the farming lands and check that okay, the plants are diseased and we need to take some action. Like for us human beings, if we are diseased, if I have pneumonia or someone has diabetic, we need to know that which kind of disease he or she is suffering from before applying before giving him or her medicine. So same way, plants need also we should know that which kind of disease plant is suffering from before applying any pesticide or insecticides to the plants. So as per my study, I get to know that there are three parts of plant which get diseased: stem, leaf and fruit. But mostly I have seen that leaves are the part which are infected with the disease, because it is the most sensitive part as well as it is the first earliest part that grow in the plant. So and also we study more on the leaf part because the images are easily captured. They are mostly attacked by fungus, bacteria and virus. So I would like to list some of the names of the disease, mainly 2 or 4, but there are 4 to 5 which I like. It was 10 to 20 which I came across while reading previous year papers. Some of them are like brown spot, alternaria, black rot, gray spot, black measles, and others are like early blight, late blight, spider mites. These are the disease list of disease. There could be some disease which may affect only some kind of plant but cannot be seen in others. So some diseases are common to some kind of plant because they grow in some part of the region, and the bacteria, fungus which attack those plants are prone to that weather condition. So some common disease cannot be found in all plants. So while reading previous year papers from last 3 years, here are some techniques which I came across. Many people, many researchers have used image processing, deep learning, fuzzy neural network, and some of them has also built expert system to give advice that which kind of disease it is, or which kind of action should be taken. So and classification techniques which those people used were clustering, KNN, SVM, and decision tree. And while reading those, I came across which were the best technique for the classification as well. So in image processing techniques, first step is like image acquisition, collection of the images. Either it can be collected with the simple camera from the farm, or there are different methods if you want to go for different process, like hyperspectral imaging. Hyperspectral imaging needs a separate lab and actual leaf to capture the spectral range of the disease in the leaf. So that is tough. It can only be done in laboratory. But for researchers like us, we can easily get the data through online. So one of the data that I looked for was from Kaggle, which was of 2.7 GB of data set of diseased plant images. And it was also data augmented images. Data augmentation is a method like which helps us to increase number of images by distorting, rotating, adding some noise. So which can be further, we could apply some techniques to remove it, because real life images may contain blurriness or distortion or some noise in the images. So we need to train the model so that they could detect these kind of error in the image, this kind of noise in the image, and from the real time image, and then can further process it. So we need to add this kind of images while training the model, deep learning model. So image pre-processing is like when we are capturing the images, different images may be of different sizes. Some may be large, some may be of high resolution, containing more number of pixels, and some may be having less number of pixels. So we, while training the data, need to adjust or resize the complete set of images equally. So this comes under image pre-processing. And equalizing the resolution. Also, some of the images may have high pitch at the end, in the corner side. So histogram equalization method can be used to equalize the image. Also, I came through a method like we may also train a deep learning model with RGB images, but it will be taking more number of time, because RGB image has pixel values from 0 to 255. So calculation on the training time will be more. So we can convert the image to grayscale, which is ranging from 0 to 1, and because of that the training time can decrease again. And the next is like, this is the image segmentation part. We need to study only the diseased part. So image segmentation will help us to extract that part of the image which are only diseased and left out the other part. So because of this we can only work on the important part and left out the other part. The methods which I came across was k-mean, thresholding, and histogram. I also came across like, when we are using RGB image, k-mean clustering method is appropriate to do image segmentation. While when we are working with grayscale images, histogram method is the best. Thresholding images like may not give us appropriate result because it takes a value and excludes the region if it is greater than that, if the pixels are greater than that. So according to me, if I am converting my image from RGB to grayscale, and then applying histogram segmentation to do the further processing. Here are some images of plant disease and segmentation done. And then if we are particularly working on image processing, then we will further go for feature extraction, and then we can go for classification. But I am focusing more on deep learning part. So yes, I discussed this hyperspectral imaging method to extract spectral range of the diseased part in the leaves. This needs an actual lab. Leaves are brought from outside field and kept, and with that there are two camera lens which captures the image, which captures the spectral ranges. Like for example, zebra chip disease, which is found in potato. This is the range. So if we are bringing a potato leaf, and if the spectral range found after from the setup, then we can consider that the potato is suffering from zebra chip disease. Similarly, now coming to the next, like before applying deep learning model, we need to do image processing, because the real images captured from real life are not always accurate. It means they are blurred, they have noises. So we need image processing to filter that out. And then if we apply deep learning method, then the accuracy of the classification becomes more. These are means deep learning includes neural network, recurrent neural network, as said, like updation of the weights, we include that. So there are different kinds of layer that we use while constructing a model, deep learning model or training model. Convolutional layer, which is convolutional 2D or 3D, and dropout layer, max pooling layer, and dense layer. Dense layer can be also called as fully connected layer, which is connected at the end after the multiple hidden layers have extracted the features, and then we need to get the classification output. So this is the architecture. Here we have multiple layers. Here it is. This is the image taken from high. We can also consider this as an image, and then input is taken in the form of data cube 3D, and then convolutional pooling, and then batch normalization layers, and then dropout layers, flatten layers are done, included to train the model. So the advantages of using deep learning model is that it increases the performance. Performance means gives us most accurate result. I have seen a paper where there was a comparison between SVM and KNN and all other BPNN techniques for classification. Among them, the deep learning model which was proposed has shown better results of classification as compared to other techniques. Also, these layers, there are multiple number of layers which also automatically discovers the features, and it improves the recognition accuracy, means classification and recognition accuracy, reduces the demand of image processing, like feature extraction. Now we do not need to do it with image processing, but it is now done by the deep learning model. Hyperparameter tuning, like when we are giving a big data, a large data set of images, then we can fit in with number of epochs, batch size, so we can tune it and to get the accurate classification output. Here are already different proposed models which has already been proposed, like LXNet model. It has 8 number of layers. We can directly import this in our model, and also can add extra multiple number of convolutional batch normalization layer as well. GoogleNet is there. GoogleNet also has specific number of layers, like it is of 34 layers. It also helps in reducing computation cost and complexity. It helps us to perform multi-scale feature extraction as well. Like if there are multiple features, it helps in that way. VGGNet comes in different, like we have VGG 16, which contains 16 layers. There can be more number of layers we can add on to that. So it contains convolutional layer, which gets doubled after each max pooling layer. Then we have overfitting, and then CIFAR. There are some models like GPCD, CNN, like global pooling dilated convolutional neural network proposed in a paper. And then there is CIFAR model. This in CIFAR model, the kernel which is used is of length 10, and max pooling which is used of length 2, and the output layer has only 4 neurons. 4 neurons means it can only classify up to 4 diseases. But if there are more number of diseases, we need more number of output neurons in the output layer. So combination of these models as well as more layers can be added to get the classification result more accurately. As I said, there are other classification techniques, KNN clustering, SVM. Among these, SVM has found better because it can separate both linearly separable and non-linearly separable data. So this has performed better, but as compared to deep learning, the accuracy of it has also been reduced. So this decision tree can only be used when we have specific number of disease, and also can be used along with hyperspectral imaging. In hyperspectral imaging, we have ranges of spectrums, and if it is greater than that spectrum, then it can be considered as this kind of disease, and if it is less than, then it can be considered of another type of disease. So decision tree has also been used to classify the disease. Backpropagation neural network is just to get correct output target equal to the target output, where the updation of weight takes place, as sir has already explained, our chairperson sir. So problem in neural network is also there. What are the problem? Like when we have vanishing gradient descent, when we have multiple numbers of layer, sometimes it takes more time for updation of the weights, and more number of layers interconnected takes more number of time, because of which the performance degrades. So these are the problems which can be faced. Degradation in training process. Degradation, again, training process consuming more number of time. There is internal covariate shift, like distribution of input data changes, because first layer may have different input data, and the output which first layer is providing may be different. So the dimension of input is changing after each layer during the process. Overfitting problems may occur when we have small data sets, and large number of parameters are there which need to be adjusted to get the accurate result. So these are some problems while learning in deep neural network. Now there are some solutions as well to this. Skipping connection. There are some connections which are repeatedly and has no use in increasing the accuracy value, so we can skip those connections. There could be transfer learning where the first layer is learned and that learning can be transferred to the another layer. Initialization strategies. We can initialize the inputs to particular layer to decrease the or to what we can do is to not change the inputs in every layer, or to what we say stabilize the dimension. Optimization strategies, as sir explained, one of the optimization strategies. There are more others like particle swarm optimization and colony optimization, which can be used to optimize these strategies. Batch normalization, and these are the solutions. Tuning hyperparameter, again tuning hyperparameter means we can tune with the batch numbers, and other parameters are also there. So my main focus will be on considering large data set, because most of the paper which I read was like having uh, either studied tomato disease or potato disease or pomegranate disease, but I would be considering all those disease and applying. My intention is to increase the accuracy. So the base paper which I took had 9 deep convolutional layers. So I would be considering these models as well as adding my own number of layers, convolutional, dropout, flattened layer, to improve the accuracy. Thank you.
Yeah, thank you, Himanshi. You have done a very good presentation. I think you went through all the details that is needed. And one thing to add for your presentation is you can actually like transfer learning is you have that existing Google Net Alexa models being trained for existing images.
Yes, sir.
So those things you can try to train it with your data set. So
Yes,
how many
sir.
classes you want to classify, whether it is a binary or multiple classes, you can segregate those output layers alone, and then you can run on the same network and take results.
Yes, sir.
And I wish you all the best. Thank you.
Thank you, sir.
Thank you. Thank you.
I would like to invite Janmya Kumar Mishra for next presentation. Himanshi, please.
Hello.
Make me host. Just wait.
Hello, are you able to hear me?
Yes, we are able to hear you.
Yeah, thank you everyone. So thanks for giving me the opportunity to present my paper. Let me share my screen.
Yes.
Okay.
Ma'am, I have made you the host.
Yes. Thank you, Himanshi. Janmya, now you are host. You can share your screen.
Okay. Okay, so I think my screen is visible now, right?
Yes, it's visible.
Okay, so my this is my paper, a survey of machine and deep learning methods for cloud computing security. So this is the outline of the presentation. This is the publication. Okay, so here the objective is actually the use of ANN, artificial neural network algorithm, to control the security issues in distributed computing or analyze intrusion detection system. So we can explore other methods also. We have mentioned here KNN, K nearest neighborhood, then decision tree, and Navy based and sub SVM. Okay. So this is the cloud computing paradigm. So as you know, there are three deployment models. So actually public, private, hybrid models. So actually public is, that means whatever the service providers we are getting the services, that will be shared by the multiple organizations, and private is dedicated for one organization, and hybrid is the combination of both. Okay. And here three service models like software as a services, platform as a services, and infrastructure as a services service models. Then roles, provider, vendor, users. Then locality, local, remote, distributed. And also features, so we can do the virtualization. So VMs, we can create multiple VMs and we can use in the cloud without creating the multiple physical systems. So we can go for the VM. So virtualization, then multiple tenants, then sustainability features, and comparison, like globalization, distributed, and service oriented. Okay, so here service delivery models. So on premises means, as you know, so infrastructure, then whatever the application data and middleware, everything will be available in on premise. Means the organization itself needs to do the setup for all the three things. Okay, so entire setup. Okay, so again the cost will increase, but in this case what happens, so we have to take the service from the cloud service provider, that is from operating system to network, and only the internal part will be the application and application data runtime and middleware. This is the infrastructure as a services. Only infrastructure part will be the service, means we have to take from cloud provider. So cloud providers like a Microsoft or Oracle or IBM, whatever. Okay. So here the platform as a services. So here internal things like application and data. Then external cloud services we have to take like from runtime to network. And here software as a services means everything will be deployed in the cloud. Okay. So here also we have to take care about the security. Suppose if here if we consider for the software as a services, means we have to more there is a more concern for the security system. So we have to make the security system stronger. Okay. So here cloud security challenges. So there are multiple challenges here. So first one is like authentication attack. So here what happens in authentication attack? So attackers are more active to break down the system, because it is actually the entry point to cloud system through authentication, whatever the login credential and all. So that's why they are more open to create the a program or algorithm to break down the system. Okay. So like for example, like so keyloggers program is there, that is to key replace events they will trap. Okay, and they will put their algorithm. Okay. And then phishing attack also is like redirect end users to fake web portals. Means in between, suppose it will looks like a real web portal, but it is not actually the real portal. It will be a fake web portal, so they'll redirect to that portal when we type the URL. Okay. And another one is like brute force attack. It is a trial and error method for the password. So multiple number of passwords, they will hit and trial methods to give an entry into the system. So next is like storage based attack. So here what happens, like attack on storage devices to steal the important data. So cloud means again there is a data, and day by day the data is also increasing, because data is also increasing because a lot of data, images and all. So they're trying to hit the storage system, that is by putting the algorithm or putting the program into our system or VM in the cloud system. Okay. Then third one is the malware injection attack. So here what happens, like malicious subcode is positioned inside the virtual machine. Okay. Virtual machine image actually, not exactly virtual image. So VM image actually what happens, like when we take the backup of the entire system, that is like we can say like a VM image. So why we take the VM image? Because if we take the VM image, then we can replicate that image to create another new system somewhere. So what happens here? They're trying to inject the software or program into the VM image, and when we create the new VM by using that VM image, then that particular program or particular program will run in that VM, then it will corrupt. Okay, the intention is to corrupt the new VM. Okay, so next is man in middle attack. So here what happens, like the attacker grabs the message in the public key exchange that sent back its own public key against the requested one without the knowledge of the sender. Okay, so when the sender asks for a public key, they can arrange one public key and send to the sender without the knowledge of the sender. Okay, then denial of service attacks. So here what happens, like we can say like a DOS attack. Okay, so what happens, like here the service requests are overloaded here. Okay, and also added in the queue. So what happens, like here the new genuine requests will be in a queue and in a pipeline for a long time. So what happens, like there will be a hang, the system will be hang. Okay, and the service will be delayed. Okay, in this case. Okay, so denial of service, sometimes it is a timeout issues and all will get. Okay, and again another one is like side channel attacks. So in this case what happens, like malicious VM is placed in cloud computing by the attacker. Okay, so without the knowledge of the actual authenticated users. Okay, and last one is like application based attack. So here what happens, like challenges faced by running applications with its performance and information leakage. So here also similar kind of things like information leakage, whatever the data will be available to the attacker. Okay, so there are various techniques available here in today's scenario, and also the lot of research are going on, and the ML, machine learning and deep learning algorithms to overcome the challenge in cloud security. So this is one of the survey paper that is to how the ML we can use here, that is to reduce the attack. Okay, so there are the various not only the cloud system, there are the also integrated platform also in the today's day-to-day life also, like suppose IoT integrated with the cloud. So Internet of Things also, it is also increasing, and a lot of research are there. So that's why there the intuition detection also we need for this, and again in the cloud also, cloud itself also we need. So here what happens, like deep neural network. So deep neural network, we can use the deep neural network for this. And again, deep neural network means actually what happens, like the multiple layers of artificial neural network. Okay, so here the ANN artificial neural network, the plan is to use artificial neural network mainly the deep neural network, because next slide here. Okay, multiple layers. If we put more than 3 layers or number of layers, if we increase, then we can say like a deep neural network. So here it will be the inputs and then input node layers, then hidden node layers, then output node layers. Okay, and next is the multi-cluster ANN also. So multi-cluster ANN, actually the input layers will be there, and in a different multiple clusters, and again the workload will be distributed here, that is AW1, AW2, and so number of workloads, and then hidden layers. Okay, so if here we can increase the hidden layers. Okay, then if we increase the hidden layers, then it will be considered as the deep neural network. Then it will be the here the balance load will get here in output layer. Okay, so here there are the multiple research also already done here by using ANN. There are the techniques like the frameworks already used, also giving the output like 97.11%. That is to create the algorithms. And again, the research is going on from my end, that is to how to develop this algorithm in ANN, that is improve this algorithm, that is to stop whatever the levels of data is data leakage or whatever in application related issues or any storage data leakage and all. Okay, and also here in future research also, like the expose deep neural networks and ML data sets also. There is a collection of AI data sets across several fields. Also here we can use that is applied for the security, and also we have to make more research on this. That is how to take care all these data sets and all. Okay, and again that is the machine learning also improved significantly in past few years, and again still some challenges also we are facing, but still we can go for the ANN, artificial neural network, or we can use the KNN, k nearest neighborhoods, or we can go through the decision trees or navy base. There are multiple methods, or you can go with the SVM. But in my case, I'm using and I'm using and developing the algorithm that is in artificial neural network. Okay, so yeah, that's it.
Yeah, thank you. That was actually a good presentation.
Thank you,
Which
sir.
you have taken as a base thing to improve upon? Can I know
Sir,
which model are you trying to take up and improve upon?
yeah, that is in artificial neural network. So I am using MATLAB. Okay, so MATLAB I already used earlier. That is say for the Pitman shorthand. That is say already published the paper, the neural network based method to recognize the handwritten English Pitman shorthand. Okay, so here I am trying to improve that same algorithm already used in MATLAB. Okay, so in that technique, what I use the multiple images. I have taken from number of like around 20 to 30 people I have taken. That is the handwritten images. That is for the Pitman shorthand, and process that all these images using that algorithm. Okay, so same algorithm here I am improving. Okay, so for the intrusion detection techniques, that is the ANN method,
Okay, that's
artificial
good.
neural network.
Any parameters study done on which parameter we can feed?
No, the still it is actually in a starting phase, so that's why
So if you
nothing in.
understand that also, I think it will be good for simulating any results. Okay.
Okay, okay, sir.
Yeah,
Thank you, sir.
thank you. Thank you.
Thank you, thank you. Yeah, thank you. Bye.
Good afternoon, all. Myself, Dr. Upinder. Today, I am concluding the first session of the International Conference on Computational Technique and Intelligence Machine. And the session is advanced. The session is chaired by Professor Jenkin Vinson, and the plenary talk is given by Valentina Elmley. And I, Dr. Upinder, on the behalf of BFG, I would like to express my expression and gratitude to the chairperson who chaired the session, and the our plenary speaker, Valentina ma'am. And the session witnessed a very useful discussion on the topics of biometric, a virtual gateway, the ANN approach, and the Valentina ma'am gave an excellent presentation on the fuzzy interpolation methodology and the fuzzy fusion techniques. Um, both the sessions are very interesting, and the session was very much appreciated by all the attendees. It was a useful interaction that is sure to motivate many aspirants. I would also like to express my thanks to all the presenters, Dandewal Lokeshwar Reddy, Deepa Devgan, Himanshi Rajput, and the Janmaya Kumar. Sharing this experience with some of the leading researcher was a golden opportunity for us, and we are thankful for that, and we look forward for the other sessions. And I would like to once again thanks to all and everyone present here, and it was a very and wonderful session we are having. And we also like to everyone express thank you. Now I would like to call the organizers.
Thank you, ma'am. On behalf of BFJ, we would like to thank our chairperson, Professor Dr. Jenkin Wenson, and co-chair, Ma'am Professor Upender Kaur, and all the guests and presenter over here. So, from the core of our heart and from the BFJ family, we would like to thank you once again.
So thanks once again, Dr. For even inviting me and putting into this stage and sharing the talk and listening to eminent personalities like Dr. Valentina, Emilia. And it was also good to have your presentations chaired. Some good papers on deep learning I could see, and machine learning. I think those would be more useful for those researchers and the research community in the coming years. A lot of contributions the papers out of this conference would bring in. I wish all the very best for the Baba Farid group of institutions. And I also thank the God for giving us the grace to hold up on so far. Thank you. Thank you all.
Thank you, sir. Thank you very much.
Thank you all.
Thank you.